buffers at work. The first part of this experiment is to make a buffer, 100 milliliters of a buffer. You are going to get assigned a pH value, and you have to then make a buffer using compounds and solutions that were prepared by yourself or other students the previous week. So I'm going to make a buffer at pH 7.8. So I would look on the sheet and well, what do I choose? How do I know what to choose for a buffer? Well, you want to choose a compound that has a pKa value very close to the pH value. So I want, if I'm going to make a buffer at pH 7.8, I want a compound that has a pKa value around 7.8. Well, the one that comes to mind that's close is tris. Okay, so if I want to I'm going to make a buffer using tris. Well, I can use, there are three different ways to make a buffer. One, I have a jar here of tris, the weak base, and a jar of tris HCl, which is the conjugate acid. So in order to make a buffer, I need both the base and the acid. So I could figure out how much base and how much acid to weigh them both out, dissolve them both in the same solution, and that would get me a buffer. But there's an easier way. I can take just one of these two compounds. And you say, well, that doesn't make a buffer. You have to have both components of a weak acid conjugate base or a weak base and a conjugate acid, both components of a system like that. Well, I already have made up a solution of tris base, 0.1 molar. So this is what I used in the titration curves experiment, what we did. And so if you remember with the titration curves, we pipetted an amount of this solution, and then we added HCl, right, which is a strong acid, and we went all the way to the equivalence point. Well, at the equivalence point, we've neutralized all the base and turned it into its conjugate acid. Well, in order to make a buffer, I don't want to neutralize all of it. I only want to neutralize part of it, because some of it I want to remain as a base, and some of it I want to protonate and turn it into its conjugate acid. So therefore, I'll have a mix. Okay, so how do I make 100 milliliters of this buffer at pH 7.8? Using this tris base solution. Well, the pKa of tris is 8.08. So if I put this solution, if I just took 100 milliliters of this solution, I do not get 8.08. And I don't get 7.8, which is what I want. Remember, because this is just the base. In order to get where the pH equals the pKa, I have to have an exact 50-50 mix of both the base and its conjugate acid. So if I put in 50 milliliters of this and 50 milliliters of 0.1 molar HCl, I would neutralize the whole thing. That wouldn't work either. So if I put in 75 milliliters of this and 25 milliliters of HCl, right, can you see how you have to kind of play around with that? But experimentally, I don't have to do all the calculations and try to figure it all out. I have a pH meter. So if I want a buffer at pH 7.8, all I have to do is choose how much tris base that I want, and then use HCl to get it to the right pH. Now, I could use 0.1 molar HCl because it's the same concentration and figure out how much volumes, but it's easier to just use 6 molar HCl. Then I don't have to add nearly as much. In fact, I'll probably only have to add a milliliter or two. So what I can do is I decide how much of this I want. I can't use 100 milliliters because then I wouldn't have any room to put in the HCl to get to the right pH. But I can put in quite a bit, maybe 90 milliliters or something like that. Measure that out into a beaker. Then use the pH meter, get it calibrated, put it in here, adjust it to the right pH using 6 molar HCl, and then once that's done, I'll have 90, 93, 92, some kind of like that milliliters. I will then transfer from the beaker to a volumetric flask and dilute it up to the mark. Because that way I'll know that I have exactly 100 milliliters of buffer. And we'll know that it'll be at the right pH because we used a pH meter. Okay, so I've put 90 milliliters of my 0.1 molar, or approximately 0.1 molar tris base, okay, that was left over from the previous experiment. And as you can see, I put in 90 milliliters. I've put in the pH probe. I've calibrated it with the pH 7 and 10 buffers because it's a base. And as you can see, when I put 90 milliliters in there, the pH isn't at the pKa, which is 8.08. It starts out much higher because all that's present is the weak base. So what I need to do to get a buffer is I need to add HCl, concentrated or strong acid, so that it lowers the pH. But I don't want to go over 100 milliliters total because otherwise I won't be able to fit it into my volumetric flask. So I'm going to use 6 molar HCl here, and I've got it on the stir plate here just so that way I can see that, and I need to get it down to what I want my buffer at, which is 7.8. If I accidentally go over, I can bring it back with some 6 molar NaOH. That'll raise the pH. So if I started with, instead of the tris base, if I would have started with a solution of tris HCl, I would have to bring up the pH using this solution. But I have to add HCl because I'm starting with the weak base. So as I'm adding the strong acid, I'm converting some of my weak base into its conjugate acid to make buffer. So you can see here 1 drop does change the pH quite a bit because it's 60 times more concentrated. So I got to get it down to 7.8. That's about, what, 10 drops? You can count them on the video here. I haven't been counting. As long as we don't go over 100 milliliters, since we only put in 90 of the original solution and it takes about 20 drops to get a milliliter, I think we'll be okay. You can see here now 1 drop of even this relatively concentrated acid doesn't change the pH very much, which means we are in the buffer range. We're going to investigate the buffer range in the rest part of the experiment, but we need to make the buffer here first. There we go. Okay. So now my solution is at pH 7.8, which is what I want. I've neutralized some of the tris base to form it into its conjugate acid, but not all of it. Now you can see it's 7.81, 7.8. It's pretty close. Now what I need to do is stop the stirring, take out the pH probe and the stir bar, and then transfer it to a 100 milliliter volumetric flask. And I want to get all the solution that's in there into here. I'll probably rinse it with a little bit of water because I'll probably need to raise it to the mark. Okay? By adding the water, I'm going to change the concentration, which will change my pH just a little bit. So I may not get exactly at 7.8, but I'll be pretty close. Okay? So it looks like as it's stirring here, it's still not quite down, so I may need one more drop of HCl here. Because the water will change the pH just a little bit, but I want to be as close as I can to 7.8 when I go to do that. Okay. Drop here. Okay. So now it's at 7.77. Okay, so we're within one drop of the 6 molar HCl of 7.8. So we're pretty close. Right, it does take a little bit to mix, a little bit of time. But we're within a drop. And so we're about ready to go. I'm not going to show you me transferring it to the volumetric flask and bringing it to the mark because you've done that before. Okay, so I finished making the buffer. I diluted it up to the mark and inverted it 15 to 20 times to mix. Now we're going to test the buffer capacity of the buffer we just made. And the way we're going to do that is through titration, of course. And so we're not going to obviously test the whole thing. We're going to test 25 milliliters. So I'm going to pipette 25 milliliters of my buffer here into this beaker. And then I'm going to titrate it with HCl, okay, which is set up here. And I'll have the pH meter and the stir plate all set up underneath it. I don't have it all set up. But I do have the burette cleaned and rinsed and filled with HCl. Then I'm going to do a separate 25 milliliter portion, pipette a separate 25 milliliter portion of my buffer into another beaker and titrate it with NaOH. All right? So I'll do that. Now I'm also going to compare the buffer capacity of my buffer. How do I know it's a buffer? I'm going to compare it to doing 25 mils of water, and I'm going to add HCl and NaOH and titrate just deionized water as well for each one. So you already know how to do titrations. You've already used the pH meter. You've used a pipette before. So at this point, I'll show you, I'll get it all set up and I'll show you some of the data. But I'm not going to record all the different titrations. I'm only going to do part of each one. Okay, so I've pipetted the buffer into the beaker, and I've got the setup all done where it's underneath the burette filled with HCl. And so the first thing to do is read off the burette and the pH to get the initial. So the initial burette reading is 0.10 milliliters. Okay, so that though is the 0 added, right? Even though the line is at 0.10. Okay, and so the initial pH is 7.84. Like I say, we were pretty close to 7.8. So in this case, what we're going to do is we're going to add HCl until it changes by 0.4 pH units. So if I'm adding HCl, the pH should go down. So I want to get it down to roughly 7.44, and then I'm going to read off the burette reading. So it doesn't matter exactly how much I add. I'm not adding specific amounts. I'm adding enough to change the pH by specific amounts. And of course, we're at the start, so we're in the buffer range. So it's going to take a little bit. Right? Because buffers resist change in pH. So we want to get down to 7.44. It's roughly where we need to get to. A little bit more. Okay, well that's close enough. And the burette reading is 3.78. So 3.78. And the pH is 7.45. Okay. Now remember that 3.78, you have to subtract off 0.1 because we didn't start right at 0 to get the amount that I've added. So now I'm going to keep going. I'm going to add more to lower it another 0.4 units. And then another 0.4 units and another 0.4 units. So we'll go, it'll be a 0.4 unit change right now, then after another 0.4 it'll be a 0.8 unit change of pH. And so that's kind of how we're going through this. So I'm not going to record all this because it's just adding it and reading off the numbers. But I'll come and show you a little bit when we titrate and show the difference with the water. Okay, so we're ready to now do the water. And so I've pipetted 25 mils of water in here, and I've got the pH meter, and I recalibrated it to using the pH 7 and 4 buffers because we're below 7. And so I need to take an initial pH reading and an initial burette reading. Now it turns out the initial burette reading is the same as the last burette reading for the buffer titration, which was 7.99 milliliters. Okay, now in this case, right, what we're going to be doing is we're only going to be adding, since this isn't a buffer, we're only going to be adding 5 drops at a time and taking different readings. So the initial pH here is 6.05, 6.06. And you say it keeps moving a little bit. Well, remember, there's not much in here for it to take a pH for the probe to read, so it's going to have a little bit more uncertainty in it when you're doing just straight deionized water. There is nothing in there for it to take a reading of. So now we're going to take 5 drops at a time, and we're going to do that 5 times. So we're going to just add 5 drops of HCl. Okay, so we don't want to add too much, but you're going to see that it has basically no buffer capacity here. Okay, so that's 5 drops. So we've added, we're up to, on the burette, .20, and the pH has dropped to 2.96. So we dropped 3 whole pH units in those 5 drops. So I'm going to do this again and again, up 5 different times, adding 5 drops and taking a reading. So again, I'm not going to record all of this. I'm just going to record the data, and you'll get that from your instructor. Okay, so I've got the buffer back in here, another 25 milliliters of the buffer, except this time my burette is filled with 0.1000 molar NaOH instead of HCl. So now I'm going to be titrating with base instead of acid. Okay, again, I recalibrated the pH meter using the 7 and the 10 buffer, since now I'm going to be going to higher pH. All right, so again, at the start, I need to take the initial burette reading, which happens to be 0.10, so it's the same as the starting for the acid, just completely by accident. And the initial pH is 7.76, right, which is a little bit different than the other buffer, but again, the pH meter has drifted a little bit, but it's within range of essentially 7.8, which was what our buffer was. Okay, well, I'm having a little trouble with the stir bar here. For some reason, it just decides to turn off every once in a while, or slow down until it stops. All right, so now we're going to go until we add 0.4 pH units. So we're going to go to 8.16. And again, so that's the only thing that we have to worry about. We do not have to worry about adding a specific amount. We're going to add enough till we get to the right pH we want. And again, we're at the start. We're in the buffer region. So it's going to take a decent amount. So you can see I'm adding quite a bit, and we're not changing the pH much at all. Okay, so now we're in the right range. And how much did I add? What's the burette reading here? Burette reading is 7.61. And pH 8.15. Okay, so again, I'm going to add another amount to get it up by another 0.4, so we need to get to 8.55. Okay. The burette reading is 13.90, and the pH 8.55. All right, so we're going to keep doing this. I'm not going to record everything, and then we'll turn it back on and we'll let you see a little bit on the water. Okay, so now we're set up to titrate 25 milliliters of water with NaOH. And you can see that the pH at the start is roughly what it was. It's a little different than what it was for the acid titration, but it'll work out just fine. So it's 6.33, and the initial volume on the burette is 33.81. So again, we're only going to do 5 portions of 5 drops, so we're only going to do that. It took roughly 33 milliliters to change the pH 2 units with the buffer, and we're going to see how much we get with 5 drops. We changed it almost 4 whole pH units for the water. And so with 5 drops, you'll be able to read the pH here, and then the burette reading is 34.05. And remember, the initial burette reading was 33.81 in this case. So you just have to subtract them to see how much we added volume-wise, the 5 drops in milliliters. So the pH is 10.24. All right, so again, I'm not going to show you the rest of this, but we're just going to continue it and get the data.